the in the cloud. So what is the various databases available and how they work, and architecturally how it is different, like that. Small things. So first thing is Snowflake is a columnar database. First thing we need to discuss is Snowflake is a columnar database. So what is meant by columnar database? Uh, so in the hard disk, whatever the data we are going to store, that will be stored in the form of some disks, some disks. So the disk will be in the format of CDs. It will be like this. Okay, so it will be
Mm.
some number of, depends upon the hard disk, number of disks will be there. So what it will do is, it will, when you are writing to the database, so it will have the memory locations in the hard disk. So when you are writing to database, it will allocate some blocks. Database will allocate some blocks to write into the database. Suppose you are taking, so if you are, this is your table store. So generally you will store the data in the form of tables, right? So tables now is nothing but rows and columns. So each row is called a record. Each row in a table is called a record. So when you are committing the data, so whatever the record available in the table, so it will go and sit in some memory location in the hard disk. So this is called block size. So depends upon the database and properties. So the block size will be different. And previously it is like 1 MB, 2 MB. In olden days it is like 1 MB, 2 MB, and 8 MB, 16 MB, 64 MB, like that. Depends upon the hard disk. It will vary. So, and again, depends upon the data. So some tables may have only 10 columns, some maybe have 20 columns, some may have hundreds of columns, maybe have 150 columns, like that. Depends upon the table. So the entire data will be there. So mostly database will try to allocate the single block of memory to the whole record. So that it can locate, so it can store at the single place. So like this, if you have number of records, it will be stored in number of blocks next to that or something like that. So it will allocate dynamically. So depends upon your data and your hard disk size, it will go and write into number of blocks. So after that, when you try to read this particular, so suppose you will fire a query like select star from the table. So at that time you are trying to read the data from your table. So at that time what will happen is, so basically the database will work with database engine will be there. Database engines will be there. By using the database engine, it will go and check in the hard disk. So out of so depends upon the data and database size and database data. So the number of blocks may be n number of blocks. It may be millions. It depends upon the data. So out of that available millions of data, so we have to fetch particular table. Suppose you are writing select star from a table. So this a table has suppose 100 records. Out of this 100 records, one record is stored in this block. So database has to identify. So it will keep on checking all the hard disks. So where is the data located for your particular record? So whatever the record whatever the select query which you are running, that particular record is available in this particular location or not, it will search all the hard disks. So like that, during this time, it is searching, right? This is called as seek time. So whatever the searching time is called as the seek time. Uh, if you know that, so suppose if you are searching for a certain item in the market, so if you know in which shop it is available, you can directly go and you purchase it or buy it from that shop. If you don't know, you will keep on searching. So that is called seek time. If you know it is available at particular place, that is called locality of reference. Or else you someone has to tell that you have to you can go and buy there in particular shop that item is available. That is called reference. So that is known as a locality of reference. So our aim is if you are writing while you are doing insert operation writing operation, you it can write anywhere, no, not an issue. So wherever the memory is free space is available, you can write it. But the problem is when you try to read that information again, so it has to go and search for the same block. So whatever you have insert, if you have insert 100, so same 100 you have to retrieve. So it should give the same result. Searching for that particular information and getting back that particular information uh, is the most important thing. So depends upon this seek time, your database performance will vary. Here in regular database like Oracle or some on-premises database in transaction, especially for OLTP transaction database, so all the records will be stored in this format. So it a record wise. So all every record wise it will store. Suppose if you consider this example, so date, store, product, customer, price, everything will be stored in single block um of memory. So when you try to search for particular item, particular product, so even though you are looking only for product name and price, so I want to search for product. Suppose some X is the product, and what is the price of this? What is the price? So even though you are searching only for two columns, it has to fetch all the columns because the memory allocated to that particular record is whole. It is for whole record, not for a single column or one or two columns. So whole record it is going to fetch first. So whole record it will fetch into memory, and from there it will try to get the required columns, whatever the columns you are trying to get. So there are SGA, PGA memory in Oracle databases. So it will fetch the data first from there to the memory area. So and they can hold record, they will fetch and put, and they will do some operations, whatever the required operations like sum or average, whatever you required. So it will do that in and fetch the result, and it will give that result. So here the
Mhm.
problem is in analytics, means in data warehousing. So we will not consider all the records. But in OLTP, it may be, suppose if you want to see information means you have to fetch all the records. But in OLAP data warehousing, we no need of getting all the records every time. So we just do cross means some limited columns reporting. So for that, I may select only for date column or product and price, not whole record every time. So at that
Mhm.
time, so for that, if but still you are fetching all the columns records. So then it will be a costly operation. That is going to be a costly operation in terms of uh, reading reading the database. So so to avoid that, so engineers came designed one new concept called columnar database. So in the columnar database, whatever the data we are going to store is a column wise. Like this, we will store for every column, not as a record. So they will allocate memory for every column like this. Suppose if you want to query for date and price, then I can directly fetch these two columns, and I can do some if you want to do some aggregation, so it will have all the dates. So directly I can do some whatever the group by operation I want to do for this, I will do on this both. So there is no need of fetching all the remaining columns. If it is of two or three, no, it is fine. But if you have, what if you have 100 columns in a table, and you are fetching every time, and which has millions of records, then it is going to be a difficult task even for a hard disk. And if you have a number of queries, mm, uh, a number of queries like 10, 20, 30 in a queue, and every time every query is trying to read all the data. So then database memory or database engine will crash. So this all happenings. To avoid that, so they came a concept with called columnar database. So for giving a high level idea, so OLTP works better for this, and OLAP works better for this. So not for all purpose, only for OLTP means for business purpose or transaction system purpose, we can use this regular database. And for analytical purpose or data science or some research purpose or mainly analytics we call simply. So that analytics purpose, so we can use for columnar database. So out of available columnar database, so Snowflake is one of the columnar database available in the market. So how it will, as I told you, how just for reference. So suppose if you have the same thing, so I have a record like this. In regularly row-oriented systems, serialized, it will be stored. Record will be stored in this format. So all record will be sent to the database like this. So it is so if it is a OLTP system, we can even for using single record, we will get the whole information. Like transaction system means we can consider online shopping like Flipkart, Amazon, whatever, or any site online shopping. So there if you are looking for one item means if you are trying to buy some X item, then you even with the reviews you are able to see what is the rating for that particular item, and what is the review for that item. Everything you are able to see at single place. So at that time it is useful to see all the data regarding that item or product. uh, so row oriented system is generally used for business purpose. And so table salaries, yeah. Suppose the same example, if you want to query for this same this is the salary wise. So if I want to query for even for single column, if I want to see how many employees having the salary of 50,000, even though I want to see only for single column data, I have to fetch all the records, whole table I have to put into memory and read this. And out of that, I have to take only single column and do the operation, like sum or average are required greater than less than 50,000, like that. We have to do certain operation. So the table depends upon the table size, then the performance will vary. So that is what here it is explained. Next is column oriented. So if you consider the column oriented, uh, then the same data is going to write in. So all the related IDs is can see the, you just remember this table. You just remember this table. This is having row ID of 001, employee ID 10, Smith Joy 60,000 salary. The whole record, one column record is placed like this. It is showing like this. So with the reference, the key thing is here we are taking one reference column like 001. It is a reference. So for employee 10, 001 as the reference we are taking, and for that reference we are keeping Smith as his name. And for 002, his name is with the reference we can say that Jones is his name. It is in different column, but we are giving reference to that particular column in the first column, so that some relation should be there, right? Otherwise we cannot fetch. Even if you are storing multiple column wise, we don't know what is which column, which item is related to which person is related to which ID, like that. Some reference should be there. So that reference we are maintaining here, instead of say giving all data record all data, we are just giving the reference. So now if you are trying to fetch the data for employee ID along with the salary, then I can simply go and search here for employee ID 22 with the reference of 004. This is the 004 reference, and his salary is 55,000. Like this, I can see. And one more advantage is, if you have multiple person has the same name. If you see here 002 and 004 has the same names, Jones. In that case, we can save like this with the same Jones, and we can give the same reference to the same person. So that instead of saving Jones two times like this, we can save with the single. We are saving some memory for that particular block. At least it will take some 1K also. So we are saving 1 kilobyte of memory. Like this, if you have a huge database, huge table, then you can save at least some MBs of data. So like this, we can minimize the size of the data, and at the same time, when you are trying to read that, we can read it column wise, so that we can simply it is easy for analytical purpose. Analytical purpose, and query performance will be improved drastically. It will take less time to write to the database, but aggregation queries will be slow because we have to search for data. And OLAP systems for writing operation will take time, but aggregation queries will run fast. Will run fast like this.